Today's video will define an integration test. Hello, I'm James Helfrich. There are four types of tests we have. There are unit tests, integration tests, system tests, and acceptance tests. This video will define the four types of tests and explain the differences between them and show how to use integration tests to give a complete understanding of the quality of the given software. Integration tests are in-code checks of software like unit tests, which exercise assembled units operating as they would in a finished system, like a system test. So let's take a look at these. First of all, a unit test operates on a single function, method, or class independent of the rest of the program. Then when unit tests pass, then we have integration tests. And integration tests how the individual units interoperate with each other. Both unit tests and integration tests are in-code checks, which verify that the code works as expected, and we use asserts to catch the errors, and we operate them with unit test frameworks. Now, once the integration tests are finished, then we assemble them together into the system and we can perform system testing. Now, system testing are black box testing. In other words, they operate on the outside of the system using public interfaces in, making no direct references to the underlying technology. They're usually exercised with automation softwares like Celerium. And once the system tests are finished, then all the known bugs are finished, then we can run our acceptance test to see if we're fit for use. Now, integration testing and unit testing are created, maintained, and executed by developers. They're written in the code, they are written as the code is written, and they're executed by developers in the course of the normal operation of the software. System tests, on the other hand, are performed, created, and maintained by software development engineers in test or by testers. It requires a different skill set to create a system test than an integration test or unit test. In other words, we have to know how to write automation software to exercise public interfaces. We catch errors with report logs. We don't catch them with asserts, and they're operated with a different framework. They're not operated with a unit test framework, but rather by automation software. And because they require a different skill set, and because it requires a different mindset to create these test cases, they're usually done by specialists, and that's why their software development engineers and testers are the ones who do them. Now, the point of system testing, integration testing, and unit testing is to find bugs. The point of acceptance testing is not. They're performed by quality assurance engineers, and they have one question and one question only. Is the product fit for use? If the answer is yes, we can ship it to the customers. If the answer is no, then we have to go back and work on it some more. So let's take a look at these in a little more detail here. Now, let's say I have a system that has two components, component one and component two, and each of those two components are going to have subcomponents, unit one and unit two for each. Now, a unit test is going to exercise each individual unit independent of the rest of the system. And in the data flow diagram, we can see this because the unit test is going to directly access unit one and look at the results back. An integration test, on the other hand, is going to exercise unit one and unit two together, as they would be in the final working system. The idea is not to isolate unit one and unit two as we do with a unit test, but rather to check their interoperation. Now, both unit tests and integration tests are inside the system, and we can tell because they're represented as processors inside the system. However, a system test is not. In a data flow diagram, we represent a system test as an interactor, which means it's outside the system. And this can use the public interfaces to exercise the system and to verify it in looking for defects. And since it's not inside the system, I cannot use asserts to find the bugs, but rather I'm going to log them up and then display them in a report after the system tests are finished. Like a system test, an acceptance test is outside the system, hence it's an interactor, but the difference is we're not looking for defects, but rather we're trying to see if we're fit for use. It has a different purpose. Integration tests are inside the system like a unit test and exercise multiple units to ensure they interoperate correctly. Now let's take a look how integration tests and unit tests are the same and they're different. And we're going to illustrate that with these three units, unit one, unit two, and unit three. Now, unit tests exercise individual units, which are classes, functions, or methods, independent from the rest of the system. So I'm going to create a suite of unit tests to exercise unit one, and then unit two, and then unit three. Now, if unit one, unit two, and unit three codepend on each other, either through inheritance or composition or any other method, my goal of my unit test is to isolate those units from each other using stubs and mocks and doubles and a bunch of other techniques. So a failed unit test can be isolated to the unit from which it's associated. Now, integration tests are different. They verify that collections of units work together the way they should. So I'm going to have one integration test that's going to exercise how unit one, unit two, and unit three interoperate. Now, here's a key point here. I expect unit tests to fail. And in fact, when I'm using test-driven development, I want to make sure they fail so I know the unit test works correctly. And if the unit tests fail, I can isolate the bug in the unit to just 1 or 2 lines of code because it's going to only exercise specific parts of that unit. Those are really easy bugs to fix. Now, integration tests are different. I don't expect them to fail. And if it does fail, it could be one of a dozen units, maybe 1,000 lines of code. It's very difficult to isolate. So this is a key point. If your integration tests fail, don't just fix the bug. First, find the unit from which the bug originates. Create a unit test to exercise that specific test case so we can find the bug in the unit test. And then once that new unit test is finished and the unit test passes, then rerun the integration test to make sure it works. We can learn more about integration testing in the integration test chapter of the software design textbook.